Into the Cretaceous period. We've talked about the first two periods of the Mesozoic, the Triassic, then the Jurassic. Now we're going to talk about the Cretaceous. The Cretaceous was a time of very high sea level. And when you have very high sea level, you also have vast epicontinental seas. In fact, during this time, our coasts were flooded with water. All the way from Boston to Miami were under many meters of seawater. And then through the center of our continent, from Minnesota, Iowa, Missouri, all of these interior states were covered by an epicontinental sea. So they actually had shorelines way back during the Cretaceous. And where you get very warm, shallow epicontinental seas, you also get a lot of chalk deposits. So chalk is a sedimentary deposit that's formed in shallow, warm basins. And it's formed from tiny little individual plankton that build up over vast periods of time. So if you look at a natural chalk deposit underneath the microscope, you can actually see coccolithophores. They are tiny planktonic algae that look like that image in the upper right. They're wild. And it is just mind-boggling to think of tiny little microscopic coccolithophores creating these huge tens of meter thick chalk deposits that we see on Earth today that were formed during the Cretaceous. And Cretaceous actually gets its name from chalk. Creta in Latin means chalk. Okay. So high sea level during the Cretaceous, we think was caused by very rapid seafloor spreading. And you might think to yourself, well, how does this make sense? If seafloors are spreading, wouldn't that make wider ocean basins and cause sea level to fall, right? Well, that's a first instinct, but it's actually a little bit more complicated than that. And it actually creates the reverse, or the reverse final effect. So as seafloors are spreading, right? Yes, basins are getting wider, ocean basins are getting wider, but they're also getting much shallower. And this is what displaces water and causes sea level rise. But remember that ocean floor is created when really hot material wells up from the asthenosphere, erupts onto the seafloor, creating new seafloor, new basalt, right? Or a new gabbro, right? Whatever happens to be made there. And this new material is fresh, which means it's really hot, really young. And hot material has a low density, right? This is why hot air rises, because it has a lower density than cold air. Same thing, hot rock floats up higher than the mantle than cold rock. So that young, fresh rock will float up higher in the mantle, creating a shallower ocean and pushing that water upward. Whereas oceans that have a very slow rate of seafloor spreading, there's a lot of time for that young hot rock to grow old and cold. And as it grows cold, it grows dense and it sinks down lower into the mantle, creating a deeper ocean basin and allowing sea level to also fall. All right, so a little bit counterintuitively, fast rates of seafloor spreading create a shallow ocean basin and high sea level, whereas slow rates of seafloor spreading create a deep ocean basin and low levels of sea level.